Hello guys, in this demo video, we're gonna introduce a competition series that we held in the past 2 years. The name is AI Olympics, and the goal is to explore the generalization abilities of agents through open competition. In recent years, there has been many excellent works in the field of decision making, such as in games and robotics. They often exhibit capabilities that surpass or closely resemble human abilities, delivering impressive performance. However, their poor generalization skills have been criticized where they often fail to transfer what they have learned to a slightly different task. As a result, to advance the research in decision making, we have first developed a physical game agent emphasizing generalization skills. At the same time, we have held a series of open competitions on top of this game, and we named the series as AI Olympics. So, what does the game do? Well, the game is quite simple. It has minimal dependencies, and within the game, each object is represented as a 2D geometry shape, as you can see in the picture. And the game also replicates physical dynamics as well as elastic collisions between items. The agent will have the ability to move. Each agent is an elastic circle that can go forward or turn at the expense of internal energy. When running out of the energy, the agent is considered dead and the player will lose control of it. As for the observability, the agent can perceive its surroundings, but only partially. It can recognize the color of an item. And normally each unique color stands for a unique characteristic of the item. For example, the black often stands for wall, where agent will bounce back when gliding. Gray often stands for guiding line, where agent can pass through. These are the basic dynamics of the game. The game also has some other features. For example, it is a two-player zero-sum game where we normally have two controllable agents. They often have conflicting interests and need to compete with each other. Both agents share the same mobility and observability for fair comparison. On top of the game engine, we can easily build multiple tasks or scenarios targeting various objectives. But the key point here is that we want each task to have the same elements on the map in order to let the agent to transfer its skills. We have built 6 sports-related scenarios and they are listed here. In the running game, 2 agents strive to reach the red goal line as fast as possible. The first agent to reach the line wins the game. It will lose speed when touching the wall, shown in the color of black, so you want run to the goal with minimal collision with the wall. And we have designed multiple maps with various difficulties, such as straight, arc, turns, and more complex maps. For the wrestling game, the agent wins by pushing the other out of bounds. In table hockey and football, agent is required to score while playing defense at the same time. For curling, each player will in turn has the opportunity to throw its rock, and the goal is to keep the rock as close to the center as possible. For billiard game, the objective is to pocket balls of the same color. All these scenarios have completely different winning conditions, but what they have in common is the agent and the unique characteristic of the items on the map. Therefore, a well-trained agent that can complete all 6 tasks needs to first have precise control of the body and can recognize items on the map as well as inferring the goal. Then it can make decisions accordingly and showcase its generalization skills. We also host a series of competition. There are many 2 types, the preliminary competition for testing purpose and the conference competition in collaboration with the IJCAI committee for a broader impact. The competition series starts from 2021 till now. Each competition has attracted numbers of participants, and we are still looking forward to extending it this year. Next is the evaluation protocol, which is the way we evaluate the agents. We held the competition on GD, which is an online agent evaluation platform just like Kaggle. But instead of on data science specifically, we focus on decision-making tasks. The platform offers online evaluation service for submitted agents in various environments, and it currently has over 5,000 registered users and has received nearly 4,000 copies of submissions. The evaluation procedure goes like this. The user will first make an agent submission on our website, and the backend server will start the evaluation process. When the evaluation ends, the results are updated to the live ranking webpage, providing timely feedback to the user regarding the performance. For the competition, we adopt the Suite System tournament, which has been widely used in chess and other sports games in real life. The competition evaluates agents' ability to complete the tasks, as well as generalize its skills across various aspects. This includes across map layouts, tasks, and opponents. For the map layout, we add unseen maps at each round of the evaluation, so that we want the agent to do as good on the new maps. For the task generalization, we random shuffle the task order, so that the agent cannot finish the game by simply remembering the action sequences. For the opponent's generalization, we sample agent pairs for evaluation, and let the participants to compete with each other, so that each agent will play with an unseen opponent. By looking at the generalization from these three aspects, we aim to explore how participants handle such complex tasks. And here are some interesting findings during the competition series. In the running competition, we discovered that as the competition proceeds, the submitted agent shows an improving mobility on the new maps introduced in each round of evaluation. This is exactly what we expect since the release of new maps provides more training data to the participants. And generalization skills do improve with more data involved. Second finding is that even though we have randomly shuffled the task orders, many agents are still capable of completing this multitask problem, and some of them clearly have shown adaptive behavior, such as in curling. At the meantime, agents has learned strong competitive behavior during the competition. For example, in running, the green agent will push the opponent onto the wall to slow it down. In wrestling, the blue agent exhibits an excellent wrestling skills, and it even learns to lure the opponent towards the boundary. In billiard, the red agent strategically positions the ball to block a bucket. These have demonstrated that the participants indeed consider the influence of the opponent and have learned counter strategy to win the game. At last, we have interviewed some of the participants and we summarize some of the methodology they have used for the competitions, such as reinforcement learning and CV techniques as the backbone algorithm, using learning from demonstration to accelerate training, adopting self-play framework to get more robust policy, and etc. Most participants are not restricted to a singular method, but has explored and combined multiple approaches. In contrast to state-of-the-art methods in academia, this competition underscored the practicality of machine learning methods and offered valuable engineering insights to the field. So in conclusion, AI Olympics competition series has provided a unique platform for participants to showcase their expertise in the field of AI. The competition's emphasis on practicality and agent generalization skills underscore the complexity of AI research nowadays and bring insight to future research endeavors. In the future, we will keep exploring the generalization skills of agents and continue to gather community support to tackle this problem. Thank you for listening.